Hello, I welcome you all to this another interesting screencast, and the problem reads determine the reactions at the roller support A, the ball and socket joint D, and the tension in cable BC for the plate. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a plate A, B, D, and on this particular plate we have some concentrated loads, point loads, 900 newtons and 600, and then there's a rope, a cable supporting the plate at B, and then we have a roller support at A and a ball and socket joint at D. Right, so first and foremost we need to draw a free body diagram. So once we section this cable here, then we are going to have some tension forces. We have some tension force there. This tension force, we are calling it tension B. Okay. And then at the roller support at A, we only have one reaction force, which we are going to call AZ. And then at the ball and socket joint, we'll have three reactions. We'll have DZ, okay, DZ, and then we'll have in the X direction, we are going to have, that's X, right? Let me write it properly, something like that. So that one is going to be equal to our dx, and then this one, this direction like this one is going to be equal to our dy. Right, so how many unknowns do we have? We have 1, 2, 1, 2, 3, 4, 5. This is a 3D rigid body equilibrium problem. It is a 3D rigid body equilibrium problem. And in 3D, we have 6 equations of equilibrium, right? So here we have 5 unknowns. So we need a minimum of 5 equations to solve these unknowns. But the good part is, intuitively, okay, how do you say it, you already know that dy, using your intuition, right? This is the way that I want it. Using your intuition and your engineering judgment, you already know that dy, we do not have any applied force in that direction. Therefore, dy, we expect it to be 0, which makes the work easier. So is also dx. So effectively, we only have 3 unknowns, okay? 3 unknowns, even when they are 5, but we already know the others are equal to 0 when we apply the equations of equilibrium, right? Which makes the work easier, but we need to show it, right? Let's show what I'm talking about. All right, so let's start with the summation of forces in the x direction. Summation of forces in the x equal to 0. What do we have? In the x direction, we have dx equal to 0. There's only dx. All right. Then we have summation of forces in the y direction equal to 0. What do we have? Again, we only have dy equal to 0. Great. 0 what? We say 0 newtons, right? 0 newtons like that. So that is complete. All right. And then we have summation of forces in the z axis equal to 0. What do we have? There we have a lot of forces. We have a B, a tension force. We have the reaction force AZ. We have another reaction force DZ. And then we have the applied forces 900 minus 600 equal to 0. Great. So this is cool. This is great. Okay, so now let's again apply the other equations, which are, all right. So let's start with summation. We start with summation of moments about the x-axis equal to 0. All right. So summation of moments. So again, we are using the right hand thumb rule. Okay, if the thumb points, the curled fingers show. So you have this. Okay, you have the curled fingers. These fingers, they show the direction. I mean the rotation, whether it is clockwise or anti-clockwise. The fingers, and then the thumb shows the direction. Okay, the direction. So if the direction is pointing towards the positive axis, then that moment is positive. If the thumb is pointing in the opposite direction, then the moment is negative, right? Great. So now let's find let's find the summation of moments about the x-axis. So we have 900 it will cause what is causing a negative moment, right? Because the thumb, you see, this tends to rotate this body like this, right? You see, so if it's in this direction like this, right? It's in this direction. The thumb is pointing in the opposite direction of our x-axis, therefore this is negative. So we'll have this value as minus. Okay, let me write there. So this is going to be equal to minus 900 times the lever arm. What's the lever arm there? That is a 0.1, right? 0.1. Okay. And then 600, it also give us a negative. 600 times the lever arm is 0.5. Okay. Then we have AZ will not cause any moment. AZ, because it is the lever arm is just equal to 0, therefore the moment about the x-axis will be 0 due to AZ. But DZ, it will cause a positive. It is causing a positive moment about x-axis. So that is DZ times the lever arm. The lever arm is 0.3 plus 0.5, which is 0.8, equal to 0. All right. Great. So we can simplify that. So we have a minus 900 by 0.1. So 0.1 minus 600 by 0.5. So this gives us a minus 390. A minus 390 plus 0.8. A minus 390 plus 0.8 dz equal to 0. So we'll have here dz equal to, dz to be equal to 390 divided by 0.8. So we'll have dz equal to 487.5 pounds. Right? It's pounds, Newton, sorry. How do I go to pounds, Newtons. Great. Then we have summation of moments about the y-axis equal to 0. The y-axis, what do we have? The y-axis, the applied forces, they are going to cause a positive moment about both of them, 900 and 600, using the right hand thumb rule. They will cause a positive moment, right? So we are going to have 900 times, what's the lever arm there? 0.4 plus 0.2, which is 0.6. And then plus 600. What is the lever arm? Is 0.2. Then AZ will cause negative moment about the y-axis. So it will be AZ by 0 0.4 plus 0 0.4 plus 0.2, which is a 1. dz will not cause any moment about the y-axis because the lever arm is equal to 0. So is B, tension B will not cause any moment about the y-axis. Okay. It will not cause any moment about the y-axis because this lever arm is equal to 0. Just like it failed to cause any moment about the x-axis because this lever arm also is equal to what? 0. So this will equate it equal to 0. Therefore, if we were to simplify that further, we have a 900 by 0.6 plus 600 by 0.2. So this gives us a 660 minus AZ equal to 0. Therefore, AZ is just going to be equal to 660 newtons. So let's get back to, of course, you will start asking, but why didn't we go ahead to say summation of moments about the z-axis? There's really no need because we have already done the three most important equations, but for the sake of just doing it so that you know what is going to come out, we'll do it, but it will not give us anything because we've already found what dx is equal to. It is equal to 0, but let's still do it. So summation of moments about the z-axis, we have one force that is going to cause moment about the moment about the z-axis, and is causing a negative moment. dy will not cause any moment because its lever arm is equal to 0, only dz, but dz itself will just be equal to 0 also, right? You'll see what I'm talking about. So the moment about the z-axis will have negative dx by the lever arm 0.8, but this is just equal to 0, which just confirms again that dx, which we already found here, is equal to what? Is equal to 0. So this I just had to show it, but it was not necessary. Okay. So now let's go to this equation. This equation, I'll write it down here. So we have a b. Let me just copy it and bring it down here so that we solve it. Okay. There we go. So let me bring it here. So we already know what AZ is. AZ, we found it as equal to 660, and we also found DZ, which is equal to 487.5. So if we are to solve this particular equation, our B therefore, let me put it down, our B therefore will just be equal to, let's find what B is, 660 plus 487.5 minus 900 minus 600. So we have B equal to 352.5 newtons. Let me do it again. 660 plus 487.5 minus 900 minus 600, 352.5. Okay, so our B is just going to be equal to 352.5 newtons, and then we have dy equal to 0 newtons, and then we have dx equal to 0 newtons, then we have dz equal to 487.5 newtons, and then we have az equal to 660 newtons. Let me just outline all the solutions. Dx is equal to 0, alright. Dy is also equal to 0. Dz is equal to 487.5, and AZ is equal to 616. And then finally our B, which is the tension force, is equal to 352.5. This is about it. This is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.